Okay, the first thing I want to talk about is just communication in general, just how we speak and talk. Um, sort of the physics of that. When I speak, I'm passing air past my vocal cords. The vocal cords vibrate. It comes out of my mouth. It's vibrating in the air. It's going across the air, and it hits. It's channeled into your ear. It hits your eardrum. Your eardrum is doing the same vibrations my vocal cords are. Your brain translates that and says, this vibration means this. And then you can take individual sounds, phonics. We talk about, language, individual parts of words, put the words together and they have meaning, and that's how we communicate. So my vocal cord vibration needs to get to your ear somehow for you to be able to hear me when we talk about voice communication. Everybody familiar with that? Feel good with that? Okay, when we're doing that, sometimes we want to be talking further than we can yell or shout, and that would be considered telecommunications. I'm sorry, telephone systems. Telecommunications is any way of communicating. Phone is phonics or voice, and we want to work with a telephone. Now, if we think, very, very generically, a form of telephone would be the paper cup and string. Anybody do that as a kid? Or last week? Or yesterday? Yeah, what's the point of that? How does that work? It doesn't actually work? Sure, sure. If you do it right, there's some things. What's actually happening? Correct. I have the same vibrations from my vocal cords are still coming out and going through the air, but instead of traveling all the way through the air from here to there, it hits something else, like a paper cup, something like that. Sometimes they use a tin can, but a paper cup actually vibrates better. And then that starts to vibrate. And then we have a tight string. Now, you can't be a loose string because you need to have a tight string into the two areas. And then the string vibrates. At the other end, the string vibrates the other paper cup, and the paper cup then vibrates the air. The air movement goes to your ear, eardrum, brain, same concept. What's the advantage of the string over the air? Air has more resistance. Something solid is going to be much more transmitting vibration than air is going to. There's a lot of space in air. There's a lot of space for it. When it's compressing and decompressing for vibrating, there's a lot of space in there. If it's solid, they're closer together and they're going to vibrate much more tightly or more consistently. It's like taking like a wooden dowel and putting it up to your ear, or a cup against the door, or something like that. It's actually vibrating through there much faster, much easier. Anybody put their ear on the railroad tracks to hear the train coming? Not when the train's right there. That'd be a bad idea. But, you can hear things far, far off because it travels through the rails or travels through the ground much further than you're capable to. Okay, so that's actually one form, a very mechanical form. Now, that's kind of limiting. We can't have individual tight strings stretched between every house. That's just not going to work. There's a limit to that. So the next iteration of telephone systems was electrical. And now we're taking that you're taking that voice and converting into electrical signal. The electrical signal is still directly reflecting the vibration of your voice. So when you take your voice and it's coming out of your mouth again and it's hitting a membrane in a microphone, it's two pieces of metal that are really close to each other, and as they get closer together, it's causing a higher voltage, and as you go further apart, there's less voltage, and as I go back and forth, I'm creating varying amounts of voltages. And as I go across that, being electrical, I can send that a whole lot further. And I can send it across town, across the state, across the country, and I can even do it around the world if you have enough stuff in between. But all that is varying voltages. On the other end, what's going to happen? Anybody play with electromagnets ever? Where you like wrap the screw with a coil and you apply electricity to it and it was a magnet, you're doing the same thing at the other end, except it's a variable magnet in that, you pull a little bit and it goes this close. You pull a lot, it goes this close. You release it, it comes back. Boy, that's kind of motion and movement, isn't it? That's vibration. And it's exactly the same representation of what happens on one end. It's going to be reproduced on the other end, causing vibration in the air, in a speaker, through the air to your ear, to your brain, and there's your communication. We've been doing this for a very, very long time. That has been our telephone system since it was invented by Edison. And we've been using that same system. In fact, we're still using pretty much that same system today. What are we doing now, though? What's the newer trend? Digital. How is it different? Different way of actually taking that voice vibration at the one end and getting to the other end. So far what we've done with air and string and electricity is that we've actually kept my voice exactly represented and just carried through different media, but I'm still getting my exact vibration of my vocal cords coming out the other end exactly the way they do it. We have computers now that kind of do things differently in the middle part of from my voice and out to the microphone to the speaker. It's no longer a direct connection. It's no longer a direct representation of one vibration here is going to be exactly represented with the vibration on the other end. I'm now taking that voice and I'm digitizing it. And that's where you mentioned like codecs. That's a coder decoder. I'm encoding this. I'm taking this voice and I'm packaging it together. And we've been doing this for a long time. How many of you have ever recorded your voice on a computer? Ever? That's what you've done. You've encoded it. You've taken my vocal cord vibrations and given a numerical value to that at different times. And in computer concepts, they've talked about that. And I think in A+, we haven't talked about it again. It's called sampling. Like how often am I going to take little samples? I'm going to do this every 100th of a second, every 10th of a second, whatever it's going to be. And then how am I going to represent that, or how accurately am I going to represent that? But it's just a representation. This sound at this point is given this value. This sound at this point is given this value. This sound at this point is given this value. And you have all numerical representation of that sound. And now it's just data. What can you do with data? Anything. Now we can do anything with data. It's the same thing as a resume file or a budget file or a picture or an email or a web page. It's all just data. So I can send it across any existing network. Even thinking of networking, going back to the string, who can you talk to? Really only one other person. I can talk to you because I have a string between you and you. If I want to talk to you, I need a different string, different cup, everything. Electrically, we can start sharing those things, but we can only do one thing at a time, and we still need to run separate wires to every house. Now we're looking at data. We still need that infrastructure, but it's already there with our data networks. As soon as you have the internet, as soon as you have a network, you already have the complete infrastructure that's required for a telephone system if we're using data, which is really, really flexible. I'm not relying on a separate telephone line, a separate telephone wire, whatever. So that's kind of the history of it. That's where we're coming from. That's where we're going. With data, we're able to send it anywhere in the world instantly because the internet is really enveloping everywhere. You know, there are places, obviously, without the internet. But for what we're working with, we're pretty well covered. A couple of other advantages of it is that we already have the infrastructure in place, and as far as the equipment goes, they don't even know or care. We talk as far as what it is, whether it's voice, a picture, a song, or document, an application. We talked last week about these phones in front of you. And we talked that saying that, well, they're not really phones, that they really are a computer. And so I'm just going to review that kind of quickly. In order to be a computer, we're talking about input, input, process, output, and storage. And this does obviously have input. If I take my receiver, I have a microphone on it, and that's a primary source of input on this telephone. Another form of input is the keypad. It also does processing. Obviously, you know, it looks like it's doing something. It booted up. It's processing something, and it does have software as an operating system and has applications all built in. It also has output. The output is the screen, so we can see what's going on and we can interact with it, and it also has its own speaker built into it. And again, the format of many of these voice over IP phones is like a traditional telephone, not because it has to be, it's because that's what people are comfortable with. If you're trying to integrate and roll out something, you know, coming up with something that looks like a computer and asking people to talk on it can be a little intimidating. Give them the same thing that they've been looking at for the last 50 years, and they can figure out how to make a call. So you're seeing more and more phones being more sophisticated, though, and you're even seeing some places not even using phones. They're using headsets. In fact, we have some headsets in the classroom, just USB. All it is this part, still giving us the same look and feel as a telephone, but really using our computer and the software built into it for our telephone. You can even go completely like a soft phone and just use your computer's microphone and speakers, or using a headset, kind of like what I'm using for recording right now. So your normal conversation will be done through the computer, dialing, answering, and everything. We will get to that later on. I think because the telephone is such a traditional form factor that we'll be working with that form first, get you used to it, and then converting it over to the soft phone idea later on. Anybody have any questions so far of any of this? Is this making sense? Yes. Yes. Absolutely. It actually boots up. It goes through its own post. It has its own operating system. We can upgrade the operating system. We can configure the software on it. We can tell it what we want it to do. Absolutely. Absolutely. It's just like an operating system in that regard, that we can upgrade it, that it does boot. It can fail to boot. So we have the same issues as well. You know, other things that, you know, even looked at before, you know, on the back we do have a network connection. Obviously it has a network interface card. It has an IP address. It has a MAC address. You know, the MAC address we looked at, you know, last week as well. It's just on the back of the computer of the phone. Let me zoom in. I don't know if I'll be able to read this or not. It's probably too much glare. Right there's your MAC address. That is my MAC address. Everybody has a different MAC address, as you've learned from Networking 1. There are no two devices in the world with the same MAC addresses. At least there shouldn't be. That would be bad. And in fact, I'm going to write that in because I'm going to have to reset it later on. So exactly as you can see, it's going to be just like a lot of other functions. In fact, there you can see the IP address, 193.15. Okay. We did this last week, but I'd like to do this again, just so that we are starting all from scratch. I'm not sure if everybody got a chance to do this, and if not, you know, this is a good practice to do this again, because sometimes working with the menus and the keys can be a little bit difficult. So we talked about the operating system. It is pre-built, it is upgradable and resettable, and that's what we're going to do right now, is to sort of wipe out all the configurations, sort of like going to a system restore point, or it's sort of going to a, kind of like an image. You know, you installed Windows 7, you got just the way you want it, now it's kind of messed up, you don't know who did what to it, and now you're resetting it back to the original installation. So to do that, let me zoom out a little bit, and we'll walk through this, and plus it'll be recorded then. We have the middle circle button, which is our menu button, OK button, and all that kind of stuff. We have the arrows that we can work with, up, down, left, and right, and then a couple other arrows and buttons that we can work with later on. If I click on the middle button, I can arrow down, and you can see there's lots of menu items. Fortunately, we don't have to use with these menus very often. There's other ways of managing this. So there's lots of things underneath here, like even under preferences, I have ringtones, ring volume, LCD contrast, download different things, display languages, all kinds of things. What we're going to do right now is just reset everything, and we'll be looking at, again, these options a little bit different way later on. If I hit Enter on Config, or the middle button on Config, I end up having an option for the factory reset. Now when I hit the factory reset, it says enter the MAC address. If you notice right now that it's highlighted on cancel, so if you just hit enter right now, it's going to cancel the resetting. To enter the MAC address, I hit the up arrow key, and now you can start typing in the MAC address. If you don't have it written down, you're just flipping the phone back and forth, So that's why it's nice to have it written down. And you just start typing in the keys to do this. Now, if for the letters, you just keep typing. It's kind of like the texting, where if you want the letter B, you would end up hitting the number 2 several times until you got the B character. I'm going to start typing this in. I'm not sure if you can see this very well, but you can sort of follow along. I'm going to do 0, 0, 0, and then I would, like in the case of B, I want to hit the number 2 a couple of times. You have to keep entering it, keep hitting that number, because if you wait, it's going to go over to the next character. Again, kind of the old texting format. And also you end up with a character that you don't want. If you end up with a character that you don't want, there's a couple ways of deleting it, and the one that I can remember at least is you can use the left and right arrow keys to move back and forth like the cursor through your MAC address. This is also nice if you skip a letter. You have all the characters in there, and also you realize the third character is missed. You can arrow left and right to get to that space where you need to insert a character. If I want to get rid of that letter B, all I have to do is I go before the letter B, and then I hit the delete key. And when I hit the delete key, it deletes the B. I, in fact, do want it, so let me put the B back. And then 820A. The other thing, when you have characters on the same key, don't go too fast. I have an A and a 2. They're both on the same key. You need to wait for a second for it to actually register the A, because if also I hit 2 again to get the number 2, I'm going to end up switching my A to a B. So just be careful with that. A, 2, 3, F, 8. And then I can arrow down, or I just hit enter. And then now the OK is highlighted. And so now I can click OK. If the phone does not reboot, you didn't type in the address right. It's not going to tell you did it wrong. It's not going to say, hey, you entered the MAC address wrong. It's just going to come back to the main menu. So in fact, here's that boot process. You can see it says booting. This is like the post and the whole boot process. It's loading the operating system. It's starting the network services. And it comes back up to your computer, to your screen that's all booted. Anybody have any questions on this? Okay, looking at the screen a little bit, I'm just going to show you the menu. We're not going to go into any of the menu items, but you can obviously do everything on here. If I hit the menu button or the round middle button, I can see the call history. I can see the status of the phone. And if I hit enter on status, it tells me my IP address. It tells me about my accounts. It tells me my the operating system versions. So there's the boot version, which is 1169, and then the actual program, which is kind of like your operating system. Right now I'm running 1253. It also shows my MAC address, and it shows my hardware version of the actual hardware of the phone. And there are different versions out there of different phones, part number, and so on. If I ever want to exit out of a menu, I hit the left arrow key, and that sort of takes me back through a menu. I can look at a phone book, LDAP directory, instant messaging, going down to direct IP call, which we looked at last week. We'll look again later on in a bit. If I hit enter on preferences, I have a do not disturb. It's going to say, don't ring my phone. I can change a ringtone, ring volume, LCD contrast. This is probably one of the only things that you might want to change on your phone. If you hit enter on there, you can change your contrast, let's see, one way or the other, to make it easier or harder to see. It depends what angle the phone is, what the lighting conditions are in the room, and everything. If I hit enter on there, it just brings you back. Display languages, if you're really into Chinese, you can switch it to Chinese. I'm not going to. I would never know how to get back out. I guess I have to reset it. If I could find the reset menu, and I couldn't click back. Configuration, it has everything in here as well. Your whole network configuration, just like a computer. I have the IP settings. I have whether it's going to be a dynamic or static. What is the IP address going to be? It needs a network mask, a subnet mask. It needs a default gateway. It needs DNS servers, all that kind of stuff. Now, working with the screen and working with the menus and the buttons, you can see it's kind of not the easiest to work with, especially if you're doing like long numbers and lots of things to enter. Fortunately, we don't have to do a lot on here. We can do a lot through a web browser. So I'm going to arrow all the way back to my main screen, and on the main page it says, right on the screen, it tells me my IP address always. It's 172.16.193.15. So 172.16.193.15. If I type that into a web browser, it brings me up to the GrandStream device configuration. It's basically remote administration for your phone. And it's a graphical interface instead of a text-based menu, up and down, left, right, multiple A's in order to get my number, whatever configuration. The default admin, there's two different passwords for here. There's a user password, so a user can actually go in and change some of their own settings on their own phone. That's kind of limited. It only lets them change a couple things on it. You don't want them to do a lot with it, but there is that capability that a user can have just a user password. By the way, there is no usernames and passwords, so you can't have multiple accounts. There's just an admin level and a user level. Yes? Okay, so the admin password for the GrandStream phones is admin. And when you type in admin, you get logged in. Now, one thing to be very, very careful about this, and it's probably going to happen to me several times because I'll be talking a lot, is that this will time out automatically. So if you don't interact with the screen, even if you interact with the screen, if you don't end up making your changes and clicking update, which is kind of like your save button, it's going to time out on you but not tell you, which is interesting because you go through here and you change that and this and this and that, and then you talk a little bit and you say, oh, let me click update, and then it says, oh, please log in, and none of your changes took effect. So I'm going to try to go through this. I might have to go through a little bit quickly just to keep the screen active on there. But as soon as you click update, well, then you can hang out on the screen for a while and you can talk about things. And then as soon as you click update, it does get written to the storage. In fact, I didn't mention that. That's the last part of a computer. Input, process, output, and storage, it does have flash memory in it. So this configuration is saved in flash memory. You can download ringtones. You can actually take songs and convert them to GrandStream. That's the name of the company that makes these phones, to GrandStream ringtones. You can, put pictures on the back of your screen. You can do all kinds of different stuff. So it does have actual storage. Okay, I don't want to actually make those changes, so don't follow along with that. And it actually logged me out already. So going through here, we have, remember that status screen that we looked at on our phone? This is the same screen, except all in one place. It gives me my MAC address. It gives me my IP address. It gave me that hardware version, remember 1.1a. It didn't have a part number for this specific phone. Some of your phones have part numbers. And then it gives me my software versions, like 1169 is my bootloader, and then the actual program, the operating system of the phone is 1253. It gives the system time and date, and then my accounts that are on there, and that'll make more sense later on. Just curious, is everybody on 1253? No? Is everybody else on 1253? You're not? What are you on? Okay. So there's a couple different versions out there, and that's actually the next thing we'll be doing is working with actually upgrading everybody to have the same one. And it's actually pretty easy. If I look at other things, though, so that just gives me status. The basic settings are, in fact, pretty basic settings. One thing is, at this level, I can change the end user password. So this would be, for them logging in and changing those couple things that they can change. The default is, I have to look it up. I don't remember. Oh, it's easy to look up, though. Let me go back to my notes. Anyway, so that you can change the end user password. Next thing that we do want to change, though, is right now it's DHCP, so it's dynamically assigned. So every time you turn your phone on, you could get a different IP address. And that can be a problem, because if you get a different IP address, all of a sudden you go back to refresh your browser, and you have an IP address, and you type it in, and then you go to admin, and you make changes, and that kind of stuff. You're actually configuring somebody else's phone. And this happens every single year where somebody has everything set up and then somebody resets it or deletes it, or why isn't my phone ringing? Oh, it's not connected to the right server, it's the wrong IP address, and so on. So to clarify that, and it's a good practice anyway with any IP system, whether it's a server or a printer or a phone, it really should have a static IP address. So you know what that device is all the time. So let me see if I waited too long. Nope, I'm good. Okay, so we're going to do that first. And we're going to click on, we want to statically assign it. I don't want to use DHCP. I want to statically assign it. And the IP, because it's on the classroom's network, we need to use a classroom network IP address. So we're using 172.16.207, and then we're using a 1, and then putting your computer workstation number behind it. So I'm the instructor, so I'm 00. James would be 11, you'd be 12, 13, 14, just going that way. So that phone's IP address will be a 1, and then the computer workstation that you're at. So 21, 31, 41. No, you're the 4th row, 3rd computer. So your workstation is 43. Correct. Yep. And I'm just going to keep moving along to save. Well, let me just click save. I talked too long. Here, I'll put them in, and then I'll keep it up on the screen. Oops, wrong one. Basic settings. Statically assign. 172.16.207.100. Subnet mask of 255.255.240.0. The gateway, 172.16.192.1. And then the DNS servers are, actually let's use Google's, 8.8.8 and 8.8.4.4. We're just going to go that far and click Update. And it does want you to reboot your computer. So go ahead and reboot. I'll come back into the screen in a second. Eight dot eight dot eight dot eight and 8.8.8. I'm sorry, 8.8.4.4. And I'll come back to that screen in just a second. The subnet mask is 255.255.240.0. And that's the classroom. So we're not making that up. I mean, we're not just saying, hey, let's make it whatever we want. That is the actual network configuration for this specific area. If you went to Gordy's room, it'd be a different IP address and a different default gateway. If you went to the library, it'd be a different default gateway and a different, actually the subnet mask is the same. 172.16.192.1. And sometimes these phones just don't reboot right. So if it hangs on the booting, just unplug it and plug it back in. Yeah, mine had been, but actually I just switched the phone. Because I had some sticky keys, so I switched the phone. Actually, I'm going to put it right in right now. So the IP address is 172.16.207.1xx. Subnet mask is 255.255.240.0, and the gateway 172.16.192.1. And the DNS servers are, should do this differently. DNS server 2 should be 8.8.4.4. Phones don't need to really do a DNS lookup very often. However, actually for the phone, for the upgrades, they do. So, all right. So for IP address? If you look at mine right now, I rebooted my phone. It's 172.16.207.100. And that's exactly what it should be. So yours should be, again, 111, 112, 113, 114, which is really nice right now. So I can always know Randy's phone will always be 172.16.207.144. So that is that location. That's really nice if you do it in an industry as well, so you always know where they are. You could do it by room number. You could do it by person's extension. I actually use these same phones and the same system at home, and I do it by extension. So I know that that extension is that IP address. So if it's extension 105, it's .105. It's the IP address as well. So it's easy to remotely configure this. Now, obviously, I don't have to be next to my phone. If I wanted to look at, Jim's phone right now, all I have to do is type in 172.16.207.145, and I can configure that remotely. I don't have to be by the phone. These are lower-end phones. They do have some issues. You get a higher enterprise quality phone, and it's pretty much more reliable. Like if it locks up during reboot, you have to go there and actually unplug it and plug it back in. That doesn't happen on higher-end phones. So, but it's just where we're at. Okay, everybody good with that? Everybody their phone rebooted? Okay. I'm sorry? You can always go back and double check. So going back into, you know, your, yeah, but I mean, you should definitely go back right now and double check 172.16.207.100, and make sure that you're always using that IP address from now on. Under basic settings, 255.240.0, 172.16.192. So everything looks good. Scrolling down a little bit, we're going to be on the same screen here under the basic settings. Under the basic settings, there's some multi-purpose keys. We'll come back probably later on and program those. Those are the keys on the right-hand side of the phone, where the white label is with all those buttons. Those are multi-function keys. You can tell them what to do. Towards the bottom of it, it says the time zone. And right now it says, mine says Greenwich Mean Time -5, and we are actually -6. So we're Central Time. And do we follow daylight savings times rules? We do. And we click yes. And encoded in here is how daylight savings time starts and ends. And I always have to look this up if I have to change it. I just rely on them. And, you know, hopefully they have the latest updates. Unfortunately, we seem to be changing daylight savings times rules all the time. Let's move that back 2 more weeks. Let's move this up another week. So you might have to tweak that. The LCD backlight is always on. That's off by default. I'm actually turning it back on because I do want it on. It seems to be easier to read when I was using that. Realize that it's on all the time. We're turning off the phones then between classes, so it's not going to be a huge deal. So you can turn the LCD screen backlight on all the time for you. It's a 12-hour format, unless you want a 24-hour clock, like being military time, like 1,300 hours or whatever. And the year, month, day is going to be fine. Display the clock instead of the date? No. Disable DTMF display, and we'll kind of talk about that later. Mute the ringer, disable the backlight. I just want to talk fast enough so I don't lose those settings. Okay, I didn't. Good. So I saved them. So now in that case, it did ask you to reboot, but if you notice that your backlight's probably on already, it still wants you to eventually reboot. But some functions and features happen right away, like turning your backlight on and off, like changing your hour display and changing your date month display. It keeps saying like year. I never see year display on any of them. So month and day is fine because it says Tuesday, January 22nd, and it says 9:01 a.m. So everything seems to be fine with my time zone and my daylight savings time and all that kind of stuff. So we good? Okay. Since everybody has an IP address and you got the basic settings on there, this would be a good time to take a break. We're going to come back and then do a few more advanced settings.